Hitting a home run with stats. Understanding the relationship statistics through data visualization, modeling, and win prediction. A statistical presentation for your consideration from the team at Grand Slam Analytics. Who we are. Brian Martinez, our data historian and storyteller. Frank Olomu, data cleansing, exploration, and visualization. Trevor Littlejohn, data modeling and prediction. On today's agenda we have a brief history of the game, baseball eras and insights, importance of stats in baseball, purpose of this analysis, data exploration and visualizations, variable selection and results, model development and testing, Blue Jays and Yankees verification prediction, results, and conclusion. Brief history of baseball. America's favorite pastime and first official professional sport back in the 1800s. Originally started from the English game of rounders until it was adopted in America and named baseball. The rules of the game were first written in 1845 by the New York Baseball Club, Knickerbockers. In 1876, the National League started. In 1901, the American League took off. In the next couple slides, I will talk about some different eras and some historic times in baseball's history. 1900s, dead ball era. 1920s, live ball era. 1947's, history. And 1990s through 2000s steroids era. Dead ball era. From about 1900 to 1920, it is considered to be the dead ball era. This period of time is most recognized by its low-scoring games and barely any home runs. This is the time where Babe Ruth became a legend in the sport and established himself as a heavy hitter with 29 home runs, the best at the time in the league. The term dead ball era. The term dead ball era comes from the design of the ball itself and overuse of it through all 9 innings of the game until it became wrecked, as well as scuffing and spitballing weren't illegal at this time. Live ball era. Live ball era begins in 1920 to present day. This is the era that contrasts with the dead ball era. Its name comes from the difference in offensive statistics that came from a lot of the rule changes. This is also the time where baseball became relevant again and exploded in popularity. (1947). The time when a man changed the history of the game once he signed for the Brooklyn Dodgers as their first baseman. This is none other than Jackie Robinson. This meant the end of a racial regression in professional baseball. Prior to this, black players were restricted to only play in what they would call the Negro League, which started back in the 1800s. The big change meant that any colored person was allowed to play in the league, which even allowed Jackie Robinson to be inducted into baseball's Hall of Fame back in 1962. Steroids era. This era refers to a time in Major League Baseball when numerous players were allegedly believed to be using performance-enhancing drugs. In the 1990s, Major League Baseball saw an increase in offensive results for the heavy hitters of the league. Prior to the 90s, only 3 players had reached the 50 home run mark, but by mid-90s, heavy hitters became more common. This saw the growth of the league's most prestigious club, which is the 500th club. This meant that a player had hit over 500 runs in his career. Eddie Murray becomes the 15th member in 1996, since last member Mike Smith in 1987. But between 1998 to 2009, 10 more players had joined the club, 6 of which were believed to be using performance-enhancing drugs. The league saw this as an ongoing issue, so it forced players to 2 drug tests per season without any warnings, and heftier fines were implied. Importance of stats in baseball and why you need us on your team. Stats have professionally been kept since the start of the National and American League. Keeping records of player achievements was started in the 19th century by Henry Chadwick. The recent advent of sabermetrics has created statistics drawn from greater breadth of player performance measures and playing field variables. In 1951, the Complete Encyclopedia of Baseball was released. The sports data is becoming ever more comprehensive, complete, and easier to access as technology progresses and the popularity of data analytics rises. Now on to my colleague, Frank.
Thank you very much for that. My name is Frank Colom, and I'll be taking us through the data exploration and visualization aspect of this project. I'm going to start with the purpose of this analysis, and the reason behind our analysis is one of the purposes of this is to understand the nature and the properties of these variables in the data set provided between spans 1960 to 2010. Because this is really important for us to know the data. Is the data complete? Does it have error? Does it have variables that are not needed, that are not relevant, based on what we are provided with? So we need to verify the quality and the completeness of this data set provided, as well as its relevance to our area of interest. Again, after that, then we need to do, based on what we be observing, we need to do a data cleansing if we do notice any error, if we do see anything that is not relevant, like unnamed data, unnamed headings. We are going to take all of this out, and this we're going to be showing you how we got to do that in our Jupyter notebook. So I'm going to take you to the next slide before I'll show you a little piece of this Jupyter notebook file on our area, where we are able to do cleansing through the inputs that we have, the code that we wrote on the Jupyter notebook file. So we will be going through the exploration for a given data before going into the visual aspect to get a feel of what we discovered through our data exploration. Our first step here was to import the libraries that will be useful for analysis and exploration. Not all libraries will be useful. So first of all, the ability to be able to identify the libraries that are relevant to what we've been asked to produce. So the second step is to prepare and display these variables and have a kind of gaze through it to see with our eyes we can spot one or two things. That is the essence of all of these display. It will help us to see if there's an error or whatnot, what we're expecting, if that is what is presented in the data file. So please, let's go to the next slides. I'm going to show you a little caption of the two steps we have just taken above in terms of importing the libraries and preparing and display the variables in the data set. So here, we just captioned this from notebook library from a notebook file. Yeah, so we import NumPy, pandas, matplotlib, Seaborn, and CPy, and SNS.set. This is the libraries that will be helpful for us to go through this analysis. And we're going to read this data by writing this code df_baseball equal pd.read underscore csv. That you put in the copy the location where you save this file. Like you can see in our own case, we save it on a download and we copy it from there and put it, and also have the .csv to show the file type. And this R, whenever you read this file, this data frame, now called df underscore baseball. So if I take you through the configurations that we had, the coding that we went through, you can see that all of these, we display the data here, like as I was telling you that we display the data, then we cleanse it to make sure that all of these, in the course of our cleansing, you find out that some of these were repeated, like you can see here. As you can see, the table above, we now have significantly less row when we group the data by team. This may be happening because the same team can be multiple row entries, but some teams of let's check through all of these rows and get more information. So if you go through, you can see some of these. You can see some of these NaN. This is these are value variables that we can't work with, so we're going to take them off. Those are part of the data cleansing that we're talking about. So we're going to do all of these, describe the columns in the new data cell. You can see all of our headings before we make our choice. And going down to the data types, we have integers, you have floating, you have floats. Yeah, we have integers, you have floats. So these are types, you have null. So these are all of these. If you look at it, we have 64 integer. Look at it here. You have 64 integer and you have 64. Yeah, you have 64 floats also. An object, you have 10. So these are the way we do our cleansing. And after the cleansing, we now have a clean data to work with. So I'm going to take you back again to where we are. Now, this is the selections of the variable that we intend to work with to give a statistical analysis and to identify variables that will help us to make a focus using variables selected below. We have home runs. We have unanimously choose home runs, walked allowed, games won, games lost, runs scored, game lost, strikeouts, errors, and net runs. This is the 8 variable that we have chosen unanimously to work on to go through our data modeling and prediction. All right. So the visual aspect of this, because this session is all about showing us what the data that we have, the independent variable that we have chosen, what they will look like, their relationships. So we tend to represent this in a histogram. Like I said, due to the flaws identified in our sprint 1 variable choice, so we have decided to review and recreated a new data frame to explore more in order to come up with most appropriate variable for our modeling and prediction. If you go through this graph, if you go through this histograph, you can see that they fairly have they have a normal distribution, and they barely have like some little outliers, and which represent the errors. So this is already a kind of insight from a pictorial view, an insight of what our predictions and how they are related to each other. We did not stop there. We went further to visualize this using Seaborn in a scatter plot. We use Seaborn to see the relationship again. If you compare this, you can see some other little dots that are not that are a little bit far away from the center, which shows that the outliers are still there. You have some outliers also, and which represent the error, but the concentrated part shows the normal distribution as well. So I will be rounding up this session before handing over to my colleague who is going to take us through the data modeling and prediction. Here is a kind of a snapshot, a summary of what our variables look like when we represented them on a histograph. So from our histogram, From our histograms and variables, we have normal distributions as a glimpse result of what we just visualized. From the histogram, it shows that we have some um, our variables have normal distributions and have some outliers using the selected variables. And then at this point, then I'm going to pass the ball to my colleague to take us through the data modeling and prediction.
And sum up of the first part of the sprint. So what we want to look at right now is trying to figure out if the sprint data that we used in part one was actually useful to us in our analysis. In this project, we were challenged to find the reasoning behind some of our variable choices, and when we finally looked at everything and put it all on a scale and looked at it through our specific timelines for our analysis, we kind of got to a place where we thought it might be better for us to start exploring some different variables and perhaps bringing in aggregation to our analysis so that we could potentially have a better model. And what I'm going to do right now is take you into our Jupyter Notebook file, and I'm going to show you a little bit about what I mean by our analysis and why we thought new variables needed to be selected. We were going to start mapping our variables through all the four timelines. In order to do that, we decided to use Seaborn for our analysis just because it allows us to look at things in a little bit more clear of a direction. So we took the variables that we were working with in our initial analysis. You can see them all here. And we put them into a new data frame so that we could label them based on our years, as you can see right here. And with that, you can kind of see over time, red being the oldest and blue being the newest, that there is a definite shift for something like home runs. As Brian was talking about before, the dead ball era saw much less home runs because the ball would become obviously ruined over the course of the game. And as obviously new innovations became known in the sport over time, and with the steroid use that Brian talked about, we do see an increase in home runs over time, and the distribution is always normal. So we definitely see that there is some statistical significance to something like home runs in our analysis. And if we follow along, you see the same thing with walks allowed. Definite reasoning behind there being a lot less in the past and moving up to more in the future based on how well the pitchers are performing using a better ball throughout the entire game instead of having to work with one that's worn and ruined throughout the process. And we continued on and did our analysis the same way. What was interesting to us is what started out with a lot of errors at the beginning of the game gradually shrunk and became very pinpointed in our newest timeline, which was very interesting for us to see. With all of that said, most of these variables for us didn't provide anything that we thought would be useful to us in our scenario. So what we decided to do was integrate some aggregation to further enhance the validity of our offensive statistics. And we did that based on an approach that we saw, one, when we did our run differential in our first part of the sprint, and two, with my obsession with the movie Moneyball. So using some of the stats in Moneyball, we actually went through and developed our strategy using aggregated data. And in order to aggregate that data for our use, and turn into our strategies, which you see here. So for our offensive strategy, we modeled with runs scored, slugging percentage, batting average, and stolen bases. With our defensive strategy, we modeled with earned runs, on-base percentage, strikeouts, and errors. And finally, our combination strategy, slugging, batting average, run difference, and on-base percentage. Now, you will see as we move on that things like that might be different. We did end up, as we went through the modeling process, having to select different variables in order to get our correct p-values and r-squared values, but we will talk about that more in a minute. What I want to show you, and what is significantly significant here, is the work we did to aggregate the data. So here you can see we pulled the information we needed, and then we added arithmetic in to figure out new columns that we then ended up naming appropriately. If you scroll all the way down here, you have the new ones that we created, which are our on-base percentage, our slugging average, our batting average, and our run differential. Once we developed the model that we thought was the most efficient, and ran through a whole bunch of periods of time, and using this through our variables with offense and defense, we found that the winning team and the best formulator for a model was using earned runs, on-base percentage, run difference, and errors. And as you can see, we achieved a desired R-squared value of 0.993, and all of our p-values are less than 0.5. And when we run our root mean square error, we find that on average across all the time periods, using these variables, we find that there is a difference between 6.5 games when we do our analysis. So once we use our model for prediction, we found out that in 2012 and in 2015, the actual games were 95 to 73 for the New York Yankees, and our prediction found 89 and 80. Toronto in 2012 and 2015 saw 93 and 87, where our prediction saw 99 and 81. And for our analysis, using our preferred model and variables, we found that the model was accurate to predicting games with 6.5 games. If we look at the entirety of the data set, this is a small margin and suggests that our model is accurate for analysis. So when we wrap it all up and we discuss our chosen variables and their results, as Frank walked us through, we found that normally distributed values, almost like those decisions, were made on purpose or with a pattern, as we saw with our strikeouts, our home runs, as well as our walks. Then when we did our correlation analysis, we found that aggregating the data, for example, net runs, was providing the best correlation results. So to further enhance our model and get the most optimal output, we decided to use aggregated stats in our modeling. And as a result, we were able to produce a model that was accurate to predicting the outcome of games within 6.5 games. However, I must admit that I am rather green with respect to the modeling process, and our skills can be honed further and for deeper understanding of the variables can be achieved, so a more efficient and accurate model can be built. But it can be stated that a more in-depth analysis of stats and aggregation can create a better model for defensive strategy based around pitching and getting on base. And I just want to end off by letting everyone know, even though sometimes things might be hard, like for myself, the modeling process of this assignment, never let the fear of striking out keep you from playing the game. And with that, that is our presentation.